But
Yeah,
when it's -3 like that, is it actually those coordinates are being subtracted by 3, not getting pushed to the right by 3?
that's right. And it's a little bit of a weirdness of it that yes, what you said is perfect and correct. It's you subtract three or subtract four in the case of y. Yeah.
Okay. All right, all right. All right, that one's not too tricky.
Yeah, not too bad. Do you have a test coming up here?
I actually missed it. Yeah, I got back to Tucson about 2 hours ago.
Oh,
So I
wow.
missed it was on Monday, so I think I'll either have it on Friday or today's Wednesday, yeah, so it's
It's
probably
still
on Friday.
it's still Wednesday, yes.
Yeah.
Yeah,
Couldn't remember.
although where you were, it's almost Thursday. All right, transform point A where A 4 comma 2 using the coordinate notation minus x comma y minus 4. This means to negate, so that ends up being a
Um,
minus 4 there.
minus.
You're negating that x value.
Okay. Oh, so I thought that would just be a reflection, and then the y I write like -2 because it's getting subtracted by 4.
Yes.
All right, that one's not too tricky either.
Yep, not too bad at all. The next question here is it's a graph again. Let's see how much of this we can get squeezed into this space. All right, reflect point B, which is 1 comma 4. So we're gonna actually graph that 1 comma 4. I recommend doing that. And then the line x equals 2, I would also recommend graphing that. It doesn't have to be amazing, but just some identifier.
Um, so -1, right, for reflecting.
Well, it's like you're just counting the distance. Like how far away from the line is it? 1 unit away.
Oh,
And then
oh,
it
wait,
and then
my
it
bad.
and then it
So
goes
0.14, and then I'm reflecting it over that 2 line, so then that would be 3, 4.
exactly. Yeah.
Okay, so I don't know how I let that one slip out of all of
That's
them.
okay. Now the rotations are much tougher. Did you get a reference sheet for rotations?
Um, the rotation sheet, yes, it's the one stolen from that high school. I forgot its name.
Yeah, I'm looking for it now. It's Tucker School, Tucker MS or
Right,
something.
right, right.
Yeah. So here we go. I'll snip them in. I don't remember these because it's the only time I ever help. The only time I ever do this with students. And if I were doing it on my own, I'd program it so I wouldn't have to remember these. 90 degrees clockwise about the origin. That's this last one here. Okay.
Mhm.
And what I see here is that your XY, which is 3, 4, it becomes Y negative X. So the 4 becomes your X value, and then you negate the X value
Uh,
like that.
um, rotate 90 clockwise. Okay, yeah, that makes sense. Just follow the rule. Yeah, I think it's kind of interesting the way 90 degrees clockwise, I mean counterclockwise, and then clockwise 270 just does the same thing.
Yeah. All right.
Okay, yeah, that one's not too tricky either.
So the point C2, 1, 2 comma negative 1 reflected over Y equals X. So we need to label a new point there. 2, 1. I guess I don't know why your teacher would put it right on the one that right there, but that's fine. It's reflected over the line. Sorry, 2, negative 1. Boy, that's really bad. Right there. And it's reflected over the line Y equals X. So you can actually do this one I think you can do this one without knowing the transformation, but there is a rule. There's a rule for basically everything. I mean, so let me grab this one here. It really helps to know them.
Uh-huh.
Y equals X, you switch X and Y. So the X values and the Y values, let me put it up here. They shift to -1, 2.
Negative 1, comma 2.
Yeah, they just completely switch, and you can almost
Oh, I'm not sure if you can hear me, but I think you froze.
did the screen freeze, or I'm just sort of pausing. I've been going too
Oh,
fast
okay,
lately.
my bad. I thought that
No,
your
I've
pause
been
was
I've
talking.
been I've been I've been looking back at some of my lessons. I go a little too fast, and just trying
No,
to
no, it's
one
fine.
more
It's
time.
fine.
All right, let's keep going here.
Okay, so
Plot
AB,
AB where
AB
A,
minus 1,
yeah.
3. Dilate AB by scale factor of 3 of the origin.
Okay, so that's new. The scale factor K, you multiply your coordinates by K. So you like this -1 gets multiplied by K. Then the 3 gets multiplied by K.
And then
Same with B.
so that means I'm just multiplying everything by 3.
That's it. The dilation is a multiplication. You can just think of it as dilation multiplication. They and we'll graph the original here. I'll do that in red. So -1, -1, 3, and 3 minus 2. So that's that line segment there. And then because it's dilated by a scale factor bigger than 1, it's going to get larger. -3, 9 to 9 minus 6. And like if, visually you should say, okay, yeah, that's about 3 times as big.
Uh-huh. Huh, okay, so when it says dilate, that means all the points will be getting multiplied by whatever number they
Yeah.
say. Um, okay, I don't know why, I feel like I've never done that before, but it's very easy, so I'm not very concerned, so.
Yeah. I would be more concerned about whether you're going to get these rotations and knowing all the ones that are needed,
Mhm.
because they're hard to remember because they're not intuitive. They're not like, oh yeah, that makes sense. Like switch Y and X and negate one. Um,
Oh,
it's not
yeah,
like,
I'm gonna have to just write those down. I know for the test everyone took on Monday, the teacher had all sorts of stuff like that written on the board.
okay, that's good.
So I'm just gonna and obviously she won't have it now, so I'm just gonna ask her if I can write down on notes.
Okay. Yeah, maybe, here's an idea. Why not bring in your own reference sheet? Say, is it
Yeah,
okay if I use
that's
this?
like what I should do.
And or if you're even more subtle, you can just say, oh, I thought we could have a reference sheet out.
Yeah,
Claim ignorance.
that's the way to do it. That's what someone
Yeah.
did last year. Oh, that was pretty crazy. Someone was on their phone looking up
Yeah.
answers, and the
Yeah. It's
teacher
like,
was
well,
like,
you didn't tell us.
"Yeah." She's like, "It's like, oh, it was never written that we couldn't go on our phones. You never told us." And
Yeah.
she was pretty shocked about that one.
Well, your generation's got access to a lot of stuff, so I would be even more willing to try things just because it's more accepted. Um,
Yeah, yeah.
like the guy selling candy out of his trunk at the Phoenix event. You can.
Oh my gosh.
All right. So what's next here? Use the parent function or something else. I'm not really sure what page 2 is on this.
Um, page 2, and
Where's it?
that's where it's like
Oh
sketching
yeah,
a graph
Ro
circle.
rotate the following triangle. Is that right? Maybe that
Oh,
is
my
page.
bad. I was looking at the wrong part. Yeah. Rotate the following triangle 180 about the origin. Um,
Yeah, this is good. So 180 about the origin is yet another transformation. You made the table here. This is really good. Negate X, negate Y. And only thing again, I'd really like to see the labeling. So like 2, 2 becomes minus 2, 2. That would be like S prime. B prime is the next one.
uh-huh.
Really, really want to just can get a little better on your labeling. I'm not the best, but they're expecting that.
Okay, all right.
All right, so I'm gonna just say B is fine. Let's go to 5. Is that okay?
Yeah.
All right. Reflect the parent function f of x equals absolute value of x over the line of symmetry y equals x. All right, so let's look at y equals absolute value of x. Do you remember any points on that parent function?
Um, that it's 0, 0, 1, 1, 2, 2, -2, +2.
Yeah, let's do a negative 1, 1, 0, 0, 1, 1. So notice it makes kind of a V.
Yeah.
Okay, that's the absolute value. You want to think of the absolute value as a V.
A V. All right.
Now we need to graph this line here, y equals x. Okay, and it does follow this other one here. All right, so notice that part of the curve is exactly on it, but this other part is not.
Okay, wait. So reflect it over the line of symmetry Y.
We're about to do that. We're just setting it up here. We're setting up
Okay.
the black is the original, the red is the line of symmetry. Now we will reflect in a different color here.
And then
So notice that it has to look the same but go the other way.
yeah.
And then the one that's right on the line is going to be going up the line there in red.
Um okay, wait. So what exactly is the line of symmetry again?
It's like a mirror that you're reflecting over.
Uh
Let's go look at it in a previous problem here. The line of symmetry here is 2. And see how we move that red point over it?
yeah.
It's like looking in a mirror. When you look in the mirror, you see yourself, you look the same distance away in the mirror as you do outside the mirror.
Okay, so then back down on that problem,
So if it's
the
right,
Y is so I have to use so it wouldn't just be like the Y where it's like 0, 0, 0, 0, 1, 0, 2, 0, 3.
well, you can use this. I was trying to show it to you visually. I think what I understand now is you want to use the fact that let me snip it in here. Sorry, I got all excited about doing a visual.
Yeah, no, don't worry, don't worry.
The you're wanting to use this is what I'm hearing. And
I think so.
right. So that what that does here is it means that you switch the x and the y. So it's 1, -1, 0, 0, 1, 1. And those are the points that we're graphing down here.
Okay,
I,
so
I was trying to show you that it can be done without the table because it's when you
because it's just like a
yeah, it's like an x.
okay, all right, yeah, I think I just let that one like somehow like slip somehow. So I think so the line of symmetry is that one, and then is the line of symmetry just for the y, or is it also for x?
It affects both of them. But what I was when the line of symmetry is part of the curve that you're reflecting, it stays the same.
Okay. So whether I'm doing okay, wait. So over the line y equals x, xy becomes yx. If
Yes.
it's going over the line of x, is it going x y wait no yx xy or something like that?
It's just this is it. XY becomes YX. So you just switch them.
Uh-huh.
That's it. Nothing more.
Okay. Hmm.
What I was trying to, I guess we should stick to the formulas. I was trying to do the more of the visual, but we should just stick to formulas, is what I'm hearing.
Yeah, I think so. Just like I do like learning the true understanding to it, of course. So I think just for now I need the
Yeah. All right, let's go to
formulas.
the next page here. Sketch a graph of the unit circle. All right, and it says to label the center and 4 points on the circle. Okay, so we're going to make a table X, Y, and I'm going to help here. Let's say X is, let's go -1, 0, and 1. Okay, and then so actually, let me draw it. I'm probably making this overly complicated. There's your unit circle. There's your
Uh-huh.
unit circle. There's 4 main points. It's going up, down, left, and right. Could you tell me those ordered pairs there, please?
0 0.
Nope. 0 0 is right in the middle.
Oh,
That's the
right. Yeah,
center.
sorry. 0 -1,
Okay.
and then we'd have 1 0.
Okay.
We'd have 0 +1
Okay.
and -1 0.
Good. Okay. Not sure why you're doing this, but that's what it is. Good job on that. Now let's see what the other things say because okay, I see now. Now we're going to translate it. Okay, here we go.
Okay, wait, sorry. What you say right then, I like blanked out.
We're just going to translate it here. It says to translate the unit circle from part A using the coordinate rotation below. So this time the X values go right 2, the Y values go down 3. So I'm going to grab this and I'm going to put it down here and we're going to put the new X and Y values. So the X values all go to the right 2 plus 2,
Uh-huh.
2, 3, 2, 1. And then the Y values go down 3. -4, -3, -2, -3, like that.
Okay.
So,
Um,
so 2 -4,
2 -4,
3 -3, 2 -2.
1 -3.
Yes. And so the question is does this look like a circle that's moved right 2 and down 3?
Yes.
Yes, I would agree.
And then what I originally wrote there would so when it's saying circ so this is called a coordinate notation, correct?
Yes.
And that means it's always gonna be like 0 -1 1 0 0 1 -1 0 when
Yes.
it's completely untouched.
Yes.
Can it possibly be stretched or shrunk?
Not as a circle. It can be dilated.
Hmm. And that's where it gets
That's where the
multiplied,
radius.
correct?
Yeah. So like a dilated circle would be something that looks bigger, but it's still a
Uh-huh.
circle.
Okay. All right. I guess I never heard of that one, so I guess you just don't have to worry about that one for now.
For now, so you get to pre-calculus conic sections. Okay, we need to write the equation. So the equation is x minus h squared plus y minus k squared equals r squared. Your radius has not changed. Your radius is still 1. The radius is the distance from the center out to the points.
Uh-huh.
Okay. The thing here with h and k, that's your new center. They're the opposite of what you have in here. So it's this is really confusing. It ends up being x minus 2 y plus 3 squared equals 1 squared. So see how it went from x plus 2 to x minus 2?
Yeah.
That's the difference between like explaining the transformation and then writing the equation.
X plus 2, x minus 2, y plus 3. So okay, wait. So then I'm just looking at the tables with it as well. So that's a blank plus 2. So then I add 2 to all of those, minus 3, subtract 3 of them. Okay, so I understand the table, and then so the signs are switching. Oh, okay, wait. So I'm gonna look at what it was as it started as x plus 2, y minus 3. And then I'm gonna realize once I put those actually into my coordinates, in the formula, it's gonna be moving it down 2 units
Yes.
into the right by 3.
Yes.
And then the radius is 1 squared because it just stayed the same.
Yes. You just moved it so it doesn't change.
Okay, all right. I don't that makes sense.
All right. So we can move on to C.
Yeah.
C is down here. All right. So this is what you were asking me about. It says vertical stretch of 4. So we got to go back to the original ordered pairs. And a vertical stretch of 4 only affects the y values. So the y values get multiplied by 4.
So they get all right. So unit circle for man has a vertical stretch of 4. So that's all of it's gonna get multiplied by 4. And I'll give it a pretty wild looking circle. And then
So
that
this is no longer a circle now. This is called an ellipse.
an ellipse. All right. I'd call it an oval.
Yeah, it's out of scope for this class. You can't believe it's being asked, but that is what they've got.
I like how it's like I'll show you all these. It's like so it's like 4 questions where you're just in like just out of shock about it. But all right. So with this one, when writing the formula, it's
So here, let's go back to the original. Okay, and then notice that what's happening is that the y values are getting bigger.
oh
So that 4 goes there in front of the y.
oh shoot. I was okay. Yeah, I don't know why I was thinking it would be like affecting the radius somehow.
It does, but and actually I've done this wrong. It's the other one that it's the other. Sorry, it actually is more than this. How do I want to do this? So this is not correct. This is the correct answer, and I don't know how to explain this without us talking about ellipses,
Uh-huh.
which is why
I'm
I don't know why they put this in here, but whatever, whatever. You can't do anything about it. Maybe ask your teacher if you're really concerned about it. Otherwise, you should probably keep going on to some new questions.
Yeah, we could just move on.
All right. Last thing I see here. I actually don't see any more. I see like a new thing, geometry unit 6 review transformations number 2. I also see some quadratic cubics, root functions. What else? Where should we go from here? Or do you want me to come up with more transformation problems?
I wouldn't mind doing some of the transform, like the parent function kind of
Okay.
transformations, just kind of go over those.
You want to go over the ones you've been given or need to pick some?
Whatever you think is best, honestly, because I feel like they'd be this pretty similar. If you think you could, if you think you got like way better examples, then we can just totally go for yours.
They're not the best. They're not the worst. So there's one here. Uh, why don't you think about the transformations? I'm just going to step away for 10 seconds. Got to just move a chair. I'll be right back.
Sounds good.
Okay. Do you have any of these transformations for me?
Um, okay. Reflect over the x-axis.
Okay.
Shoot, I thought that one would have gone first. I guess
First one's
move
it.
one unit
First
to the
one's
right.
in. Okay. Right one.
Stretch by 2.
Okay.
Then reflect, and then vertically move up 3 units.
Good. All right. So what is the parent function?
Um, it's quadratic. Quadratic.
Yes. So
And
y
that would
equals x
be,
squared. So
yeah.
let's just have you use this table here. We'll just keep it really simple. Um, minus 1, 1, 0, 1. I'm sorry, 0, 0, and 1, 1. Can you transform? You can either do it all in one sitting or uh, do them in pieces here. I'm interested in the last 3 ordered pairs.
All right. I'll do it in pieces. So then it would be 0, 1, 2
Are you talking about for
for the,
X?
yeah.
Okay.
And then it would be 1, 0, 1 for the y. And then it would be 0 to 4 for the x.
It's a vertical stretch though.
Vertical. So that's oh wait, yeah, that's y. That's my bad. It would be 0, 1, 2 for x, 2, 0, 2
Okay.
for the y. And then reflect over the x-axis. All you got to do is just write, or just, yeah, negate all of them. 0, -1, -2.
That again,
Neg
that only affects the Y's. So,
right. Okay, yeah, sorry. I know this. I don't know why I'm not
well, you're
on.
probably tired. the,
Yeah, yeah, I guess I woke up at like, I had to wake up at like 4 in the morning for Tuesday on time today, so not good, not good. Um, the x's would stay the same in that
okay.
scenario, and then 4 up would once again affect the y units. So then x is 0, 1, 2, y becomes +2, 4,
You're going up by 3 though. Up by 3.
Oh, that is my bad. That would be 1, 3, 1.
Okay, good. All right, let's try another one here.
This one's. I'm trying to remember its name. It's not absolute value. Maybe it is. Well, I can't remember its parent function name.
Can you write it though? Square root of x.
Yeah.
You can. Okay, that's good enough. Square root or root function.
All right. Yeah, this one would be left by move left 3 units.
Okay, left 3.
And then stretch 2.
Horizontal.
Right. Yeah. Horizontal stretch by 2. That's important. Reflect over the x-axis.
Okay. Does that affect x or y?
That's affecting y.
Okay.
And move down 5 units vertically.
Okay. So parent function here is 0, 0, 1, 1, 4, 2. So up to you. I just want the final one for me. You can write down whatever you want in between, but I'm going to graph it and tell you if you're right or wrong based on what you give me, and then we'll talk. So yeah, give this
Sounds
one a
good.
try and see what you come up with.
All right, I got -6, -4, and +2 is my x values, and -5, -6, -7 as my y.
I apologize. I wasn't quite ready for this. Can you go one more time? Sorry.
All good. I said my final units for x are -6, -4, and +2.
Okay.
And for my y, I said -5, -6, -7.
Okay. We're going to have some problems here. Just quickly looking at it. Let me show you the graph and see if you want to make any adjustments here to what we've got. So notice one of the reasons I know that this is not right is, like, for example, -6, -5 is definitely not on the graph. So do you want to make any adjustments, any questions for me before I kind of jump in and go through this with you?
I somehow messed up the -5. It's supposed to be -7. Correct?
Let's just go through it. Let's go through it. This was a difficult one, but it wasn't meant to be so difficult that you couldn't do it. But who knows? You could have just gone wrong in one place, and
That must have been it.
that's all that matters. So, all right, what's the first transformation? Left 3. So you're going left 3 on all the x values. -3, -2, and +1. Is that what you have?
Yeah.
Okay, the next one I had written is horizontal stretch of 2. So that affects the x. All the x's get multiplied by 2.
Mm-hmm.
Is that right?
All right. Yeah.
Wait,
Yeah, I got
whoa.
that.
I let you talk me into that, didn't I?
Oh, wait, no.
That's the problem here. Okay. So it's I gave you the wrong transformation. Sorry.
Okay, all right.
Well, wait, we still got a couple here. Well, hold on. I'm seeing a problem here. Let me try to figure this out here. Left 3. See, normally you bring that out. Don't like this. All right, I don't like this. I should not have put this 1/2 in here. So let me let me do it without the 1/2.
All right.
We'll come back and talk about that in another time. It actually converts to a vertical transformation, which is fine, but that's my fault for putting something there like that. So now when you reflect on the x-axis, that's going to change y, 0, -1, -2. And then down 5, you're going to subtract 5 from all the y's.
-5, -6, -7. Okay, yeah, I guess that was our issue. All right, yeah, so I had all those coordinates.
Good. Okay. Let's do some rotation stuff real quick here. Do you need that rotation sheet in front of you?
Yeah, might as well, I think.
Okay.
I wrote it in my notebook, but I have to use a different one currently.
All right, so here we go. Let's say I give you the point A is -4, 5, and we want a 90 degrees clockwise rotation.
90 degrees clockwise. Okay, that's gonna be xy to no, that's xy to y minus x. So then that's
Okay.
gonna be 5, +4.
Good. And let's say new B, or here is 6, -3, and we want to go 180 degree CCW counterclockwise.
Then that's gonna be xy to -x minus y. So that's gonna be -6, +3.
Good. All right, and now I want you to dilate. I want you to dilate both A and B by k equals 2. So both A and B dilate by k equals 2.
Then that would be -12, +6.
For which one?
The bot. Oh, sorry. Are you talking about?
I want you to take these original ones and dilate them and give me the new ones.
Oh, okay. My bad. I thought you were talking about the new coordinates. Then that would be -8 and 10.
Okay.
And 12 and -6.
Good. All right. So the other type of transformation that we've seen is over the line y equals x. So let's do a couple of points there. Let's say I give you this table, x prime, y prime. Let's say it's a -3, 2, 2, 3, -3, -2. Give me those new coordinates, please.
Sorry, wait. The little x1 and the y1, does that just show that it's
These are the new ones. I'm asking for the new.
okay? All right.
And using
Yeah,
this.
then that would be 2 and -3.
Okay.
3 and +2 and -2 and -2 and -3.
Okay. Now last problem here. Let's take this thing and let's run it through a k of 1/2.
K of 1/2. Then that would be -1.5. And then that would be 1, -1.5 once again. I mean, sorry, 1 and then 1.5
Good. Keep going.
and
Almost
then
there.
negative 1.5 and negative 1.
All right. You made it. You made it.
All right, we
All right.
did it.
All right. Good job here. Let's go ahead and stop the recording.